Assalamu alaikum everyone. We are from group Ephinx. My name is Mohammad Shahdad and the topic for our project is digital photography. Now I will begin with the introduction to digital photography. Photography is the process of recording visual images by capturing light rays on a light sensitive recording medium. For example, a film or a digital CCD. It can be thought of in two pursuits. One is the technical pursuit and the creative pursuit. The technical pursuit is the science of setting up the camera and the recording medium to take images in a controlled way. And the creative pursuit is the art of composing good images to capture. For our project, we will stay limited to the technical aspect of the photography and digital photography. So, how digital photography works is digital photography uses cameras containing arrays of electronic photodetectors to produce images focused by a lens as opposed to an exposure on photographic film, which was done in the past. The captured images are digitized and stored as a computer file, ready for further digital processing, viewing, electronic publishing, or digital printing. Until the advent of such technology, photographs were made by exposing light-sensitive photographic film and paper, which was processed in liquid chemical solutions to develop and stabilize the image. Digital photographs are typically created solely by computer-based photoelectrical and mechanical techniques without wet bath chemical processing. The first consumer digital cameras were marketed in the late 1990s. Professionals gravitated to digital slowly and were won over when their professional work required using digital files to fulfill the demands of employers and our clients. A faster turnaround than conventional methods would allow, starting around 2000, digital cameras were incorporated in cell phones, and in the following years, cell phone cameras became widespread, particularly due to their connectivity to social media websites and email.
The topic I am going to talk about is the digital camera and its history. A digital camera is a camera that generates digital photos that may be saved on a computer and viewed on a computer screen. Camera image sensors are based on metal oxide semiconductor, also known as MOS, which originates from MOSFET. While taking photos in a digital camera, light from the thing that is being photographed zooms into the camera lens. The incoming picture hits the image sensor chip, which breaks it up into millions of pixels. The sensor measures the color and brightness of each pixel and stores it as a number. The invention of digital camera can be divided into several generations, which are shown in the slides. The first practical camera was invented back in 1928. Since then, cameras have been evolving with the inventions of new technologies. The modern era of cameras started during mid-80s when Japan invented the active pixel sensor APS. This was enabled by advances in MOS semiconductor device fabrication, with MOSFET scaling reaching smaller micron and then sub-micron levels. The CMOS active pixel sensor was later developed at NASA's laboratory in 1993.
Today I'll be explaining digital camera sensors and their types and one lens type CMOS. The two main types of sensors are used in digital cameras today, CCD and CMOS. I shall be focusing on CMOS in this presentation. The complementary metal oxide semiconductor technology for constructing integrated circuits. CMOS technology is used in microprocessors, microcontrollers, static RAM and other digital logic circuits. CMOS technology is also used for several analog circuits such as image sensors, data converters. CMOS image sensors, the two most common types of sensors used in digital cameras today, CCD and CMOS. All the CCD and CMOS image sensors operate by exploiting the photoelectric effect to convert light into electricity. With the CMOS imager, both the photon to electron conversion and the electron to voltage conversion is done within the pixel. Some drawbacks of CCD: complex clocking requirements, high power consumption, difficulty on-chip integration of circuitry, limited frame rate. CMOS image sensors address these drawbacks by using the same technology as microprocessors and memory chips. Advantages and drawbacks of the CMOS image sensors: low power consumption, 1/3 to more than 100 times less than that of CCDs, lower cost compared to CCDs, technology on chip functionality. Present applications of CMOS image sensors: internet camera, digital still camera, machine vision, automotive, children's toys, medicine and dentistry, fingerprint ID surveillance, aerospace motion analysis, industrial inspection, quality control, process control, target tracking, spectroscopy. Overall architecture: CMOS imagers architecture can be divided into four main blocks. pixel array, analog signal processors, row and column selector, timing and control. Basic pixel structures: each pixel contains a photo detector and some transistors. This area is the heart of an image sensor, and the image quality is largely determined by the performance of this area. Active pixels and passive pixels. Circuits and APS, that is the active pixels, has 3 transistors in a pixel, while a passive pixel, the PPS, has only 1 transistor. Currently, APS are the predominant devices, although in some cases PPS are also used. The in-pixel amplifier in APS enables non-destructive read of the photodiode charge at a faster speed and a generally higher signal-to-noise ratio. Operation of a photodetector comprises of generation of free electron hole pairs due to impinging light, separation and collection of electrons in holes, production of an output signal through interaction with other components. Several popular silicon-based photosensing devices and photoconductors, PN and PIN photodiodes, phototransistors, photogates. PN junction photodiode, an important sensor for digital imaging. The potential voltage decreases when electrons accumulate. By measuring the voltage drop, the total amount of light power can be obtained. The voltage of a PD is read with a source follower. A follower transistor is placed in a pixel, and current load MB is placed in each column.
CCD sensor or charge coupled device. The digital camera has 2 types of sensors, CCD and CMOS. What is CCD? CCD or charge coupled device are sensors used in digital cameras or video cameras to record still and moving images. It is an analog device. It converts light into electrons. In digital imaging, CCD sensors are a major technology. How does CCD works? CCD is an IC that uses silicon surface to generate light-sensitive elements called pixels. When photon falls on this silicon surface, it is read by the electronics and converted into digital representation of light patterns falling on a device. Disadvantages and advantages of CCD sensor. Advantages: number 1, because of the increased surface area, there is more sensitivity and less noise. Number 2, due to the simpler structure, there are fewer faulty pixels. Number 3, the central A&D converter improves the visual uniformity. Disadvantages: number 1, as only one central A&D circuit converter digitalizes, the readout is slower. Number 2, the camera as a whole consumes more energy. Number 3, due to increased circuitry required and more sophisticated camera layouts, they are more expensive. CCD was a CMOS. In CMOS sensor, there is no direct pixel access because the CCD sensor must be read serially. When compared to CMOS sensor, there are more smearing and blooming effects when overexposing. A global shutter is used by CCD sensors, while the roll shutter is used by the CMOS sensors. Is CCD better than CMOS? In terms of power consumption, CMOS sensors are already more efficient than the CCD sensors. Then we have what is a global shutter and what is rolling shutter. Then we have uses of CCD, charge coupled devices. CCD image sensors are useful in professional, medical and scientific applications that demand high quality image data. Then CCD image architecture. The architecture consists of 3 basic functions. Number 1, charge collection. Number 2, charge transfer. Number 3, conversion of the charge into measurable voltage. Then the image here depicts the full frame transfer and interval of CCD. How is image transferred in CCD? When image capture begins, these MOS capacitors, which are basic building elements of CCD, are biased over the threshold for inversion.
So now let's talk about what megapixels are and what do we even need them for. Whenever we talk about mobile phone cameras, for a lot of people, they think that the higher the megapixel is, the better the quality, right? But it's not entirely true. Mega stands for 10 to the power of 6, which is equivalent to 1 million. Now let's take this photo for an example. This photo was taken by Xiaomi Redmi, and it has a resolution of 4160 by 3120. When you multiply them together, you'll get a value of 12,979,000, which is almost equivalent to 13 million, which is 13 megapixel. So basically this phone has 13 megapixel camera, and it is capable of recording or capturing a photo with 13 million pixels. Basically we came to the conclusion that when a camera has higher megapixel, it can capture photos with higher resolution. But as I said earlier, the higher resolution on a picture, it does not mean it has better quality. Higher resolution photos only help you when you want to zoom into a photo, or if you want to display it on a much bigger display basically. For instance, you want to download a wallpaper for your laptop, and your laptop has a resolution, your laptop display has a resolution of 720 pixel. A 720 pixel display is basically 1280 pixel times 120, which is almost equivalent to a million. So you don't need 12 megapixel photo for your display that can only emit and show 1 megapixel photos. So long story short, you don't need high resolution for every scenario. Someone might be asking, how do we get higher or better quality images if it's not related to the megapixel? Well, when you see a DSLR camera, a lot of them, they have only 8 megapixel or maybe 12 megapixel, but they capture very beautiful pictures. That is because they have much better camera sensors, and also the lenses help a lot. Just to give you a rough idea, the bigger the image sensor, the better the pixel definitions are. Image sensors capture light, so a bigger sensor captures more light, hence higher quality. Imagine the same sensor on two cameras. One is 8 megapixel, another one is 16 megapixel. The matter of fact is the 8 megapixel one will look much better. Why? Because this 16 megapixel has way more pixels in each picture. But the sensor is the same sensor. That sensor has to distribute the light among all of the pixels. So those will look, the pictures on a 16 megapixel camera will, each pixel, definitely there's way more pixels there, but the pixels will look much lower quality because not enough light was distributed on each pixel. But the photo on an 8 megapixel camera will look much better, much more crisp, and the pixels are more defined. But again, I'm just gonna clarify, having higher megapixel is not useless. It's gonna be much more useful for situations that you have a huge display. Let's say you have a display of like 70, 80 inches, 100 inches, okay? Then it's gonna be very useful to have, let's say, 20 megapixel camera to display the pictures there, because they're gonna look very good. They're not gonna look pixelated anymore. Basically, if you're looking for a camera, just see what you need the camera for depending upon your needs. If you just want a camera for your social media pictures or whatever, then you don't need a very high resolution camera.
A digital camera is a camera that captures photographs in a digital memory. Most cameras produced today are digital, largely replacing those that capture images on photographic film. So, the soul of a digital camera is its sensor to determine the image size, resolution, low light performance, depth of field, dynamic range, lenses, and even the camera's physical size. The sensor is the key. Types of sensors. The most common types of sensors are CCD, charged coupled device, and CMOS, complementary metal oxides semiconductor. CCD is one of the oldest image capture technologies for digital camera and has long offered superior image quality as compared to CMOS sensors with better dynamic range and noise control. CMOS, on the other hand, has been considered as inferior competitor to CCD, but today's CMOS sensors have been upgraded to match and even transcend the CCD standard with more built-in functionality than CCDs. CMOS sensors work more efficiently. So, smartphone cameras. The smartphone cameras are powerful tools that have essentially replace point and shoot cameras, and to be able to use one device for basically all your tech needs is incredibly convenient. On top of that, many of the pro-level features that smartphones once lacked are being incorporated into more recent iOS and Android devices. DSLRs, on the other hand, are referred to as digital single reflex camera. Digital SLR or DSLR is a digital camera that combines the optics and the mechanism of a single lens reflex camera with a digital image sensor.
I hope this video was useful and all of you could have learned something about digital photography. Don't forget to share this video with your friends. Thank you.